Have you ever looked up into the star-studded expanse of the night sky and pondered your place within the grand tapestry of the universe? Have you ever wondered about the elements that make up our world, the very essence of our existence? In this journey, we'll uncover the profound truth that connects us to the celestial bodies that adorn the heavens. Prepare to be amazed as we explore the fascinating realm of stellar evolution and discover why we are truly children of the cosmos. Embarking on a journey through the vast expanse of space, we encounter a breathtaking spectacle that has captivated humanity for millennia: the majestic life cycle of stars. These celestial powerhouses ignite in the distant reaches of galaxies. Far from our own Milky Way, they blaze across the cosmic canvas, leaving an indelible mark on the universe. When their time comes to an end, they don't fade away, but rather explode in a spectacular display of energy, scattering their remains across the cosmos. This is where the narrative takes a remarkable twist. For it is from these exploded stars that the very elements that make up our world are born. Imagine the Earth as a bustling metropolis teeming with trillions of inhabitants. Similarly, stars exist in galaxies that house trillions of stars. Just as people in a city require nourishment to survive and thrive, stars too need fuel to keep them burning brightly. Stars primarily feed on hydrogen and helium, the simplest and most abundant elements in the universe. As these elements fuse together in their scorching cores, they generate colossal amounts of energy, giving rise to the luminous glow that illuminates the darkness of space. However, not all stars follow this conventional path. There are also binary star systems where two stars orbit each other, occasionally sharing material which can lead to the formation of exotic elements such as helium. These stellar furnaces operate at extreme temperatures and pressures, forging elements heavier than iron through a process known as nuclear fusion. Iron, with its intricate structure, is considered the most stable element, making it the ultimate destination in the life cycle of many stars. When a star runs out of fuel, it can no longer generate the outward pressure needed to counteract the relentless pull of gravity. The result is a catastrophic collapse that causes the star to implode upon itself. During this dramatic implosion, the core of the star is compressed to unimaginable densities, forcing the outer layers to explode outward in a spectacular supernova. This explosion is so powerful that it can briefly outshine entire galaxies, casting their light across the cosmos. But it's not just light that gets scattered during this cosmic event. Elements that were forged in the heart of the star are also ejected into the vast expanse of space. These elements, heavier than iron, become the building blocks of new stars and planets, perpetuating the cycle of stellar evolution and ensuring the continuation of the universe's grand design. As the dust clouds drift through space, they carry with them the remnants of exploded stars, tiny particles of elements that once blazed within those celestial giants. Over eons, these particles find their way to form new stars and planets, carrying within them the echoes of their stellar origins. Our own solar system, with its central star, the Sun, the planets revolving around it, is a testament to this continuous cycle of stellar creation and destruction. It was from the ashes of exploded stars that the Earth and other rocky planets like Mars and Venus were formed. Even the Sun itself, with its blazing plasma and nuclear fusion, owes its existence to the same processes that govern the life cycle of stars across the cosmos. We, along with everything we know and love, are indeed children of the cosmos, born from the stardust that exploded from distant stars. Our bodies are a testament to the recycling of matter throughout the universe. From the oxygen we breathe to the iron in our blood, we are literally made of stars. When we gaze up at the night sky, we are witnessing the very elements that make up our world, shining back at us from their celestial arbors. The carbon in our DNA, the nitrogen in our muscles, and even the calcium in our bones, all originated from the explosive deaths of stars, enriching the interstellar medium with the very essence of life. These elements, once forged in the searing heat of stellar interiors, find their way back into new stars, continuing the cosmic cycle of creation. Our story, however, doesn't end there. We are not merely passive recipients of these cosmic gifts. We are active participants in the grand scheme of things. Through photosynthesis, plants use carbon dioxide, which contains carbon from ancient stars, to create the sugars that sustain life. Animals, including us humans, consume these plants, transferring the stellar energy into our bodies. In essence, we are eating stars. The oxygen we breathe, which enables respiration and the production of ATP, the energy currency of cells, is another byproduct of stellar nucleosynthesis. Without the oxygen released by plants through photosynthesis, our cells would suffocate, unable to harness the energy needed for survival. Furthermore, the nitrogen in our DNA, proteins, and other crucial molecules also traces its origins back to the hearts of exploded stars. This nitrogen is fixed by specialized bacteria that convert it into usable forms, allowing it to become part of amino acids, the building blocks of life. These amino acids then form proteins that play vital roles in virtually all cellular processes, from catalyzing metabolic reactions to transporting molecules across cell membranes. Additionally, the calcium in our bones and teeth, which provides structural integrity and protection, also finds its roots in the ashes of exploded stars. This calcium is absorbed from the soil by plants, which in turn become part of the food chain, nourishing our bodies and providing us with the essential minerals for strong bones and teeth. The profound interconnectedness between stars and life doesn't end with the elements. Stars also emit light and warmth, which play a crucial role in sustaining life on Earth. The light from the sun, a yellow dwarf star, provides the energy that drives photosynthesis in plants, forming the basis of most food chains. Without this energy, life as we know it could not exist. Moreover, the tilt of our planet's axis and the gravitational pull of the moon, both formed from debris ejected from the Earth's past, create tides, which have significant ecological impacts. Tides influence coastal ecosystems, air and water currents, and weather patterns, shaping the environment in which countless species, including humans, have evolved. Stars also shape Earth's atmosphere. Stellar winds can strip away light elements like hydrogen and helium from the upper atmosphere, creating a protective shield against harmful cosmic radiation. This shield allows life to flourish without being constantly bombarded by deadly particles from deep space. The magnetic fields generated by rotating, collapsing stars, known as pulsars, can extend far into space, influencing the ionization of gases in Earth's upper atmosphere. This ionization can trigger auroras and other atmospheric phenomena that not only captivate our planet but also contribute to its habitability. The connection between stars and life extends even further. Some scientists believe that organic molecules, the building blocks of life, may have originated in star-rich environments known as stellar nurseries. These nurseries are vast clouds of gas and dust where stars are born. Conditions in these regions are similar to those found on the early Earth, making them potential sites for the emergence of life's fundamental molecules. Others hypothesize that life elsewhere in the universe could have been seeded by material from exploded stars carried by comets or meteorites. These celestial travelers can transport organic compounds from one planetary system to another, potentially providing the necessary ingredients for life to take hold. As we continue to explore the cosmos,